right, so today we're doing 4.7, are talking about arithmetic sequences. So what is it, and then how can you write a recursive equation for them? So to warm up, find the next two values in these patterns. All right, so if we're looking at this, we're subtracting 4 every time we go down. So the next two are going to be 11 and then 7, and our pattern is subtracting 4. So looking at the next one, we go from 2 to 6 to 18 to 54. So we're trying to figure out what's happening here. Well, we're multiplying by 3. So the next two terms is going to be 162 and then 486. And we're multiplying by 3 for this pattern. So an arithmetic sequence is a specific type of sequence of numbers. So if you list a bunch of numbers, a list of numbers is called a sequence. And each number in that sequence is called a term. So if we're looking at this, this would be one term, but the whole thing would be a sequence. So if a pattern exists where you're adding or subtracting the same thing from each term, that sequence is called an arithmetic sequence. So these are the same from before. Here we're subtracting 4, here we're multiplying by 3. This one is not arithmetic because we're multiplying by 3, but this one is because we're subtracting 4. So this is an arithmetic sequence. And this is just a sequence. Okay, so how do we actually talk about the terms of a sequence? So like this is the first term, second term, third term, fourth term, etc. We mark them with like an A. So this is going to be A1 as the first term. This will be A2 as the second term, A3 third term, and then A4 for the fourth term. Okay, so you try. Here we have two sequences. We want to figure out what is the common difference, if there is one, and then what is the value of A6 and A8. So to go from 15 to 30 to 45 to 60, we're adding on 15 each time. So the common difference, which we'll call D, is 15. And if we want to figure out A6, we need to add on more values. So if we add on 15, we'll get to 75, and then 90, and then 105, and then 120. So this would be the sixth term. This is the eighth term if you count. We have 1, 2, 3, 4, 5, 6, 7, 8. So A6, or the sixth term, is 90. A8 is 120. So then looking at 81, 70, 59, and 48, we want to figure out the pattern. Here, our common difference is 11. So we're subtracting 11 each time. So if we keep following this pattern, you'll get 37, and then 26, and 15, and 4. Here is your sixth term and your eighth term. So A of 6 is 26. A of 8 is 4. And there are your answers. All right, so the difference between a couple formulas. We'll wait for this to catch up to me. There's two options. You can have a recursive formula or an explicit formula. So if you know it's arithmetic, we can write it two ways. The recursive formula is right here, and then this would be the explicit. For both of these, all we need is the first term and the common difference, which is D. So if we're looking at this, here's the first term is what we need. You have to list what that is, and then you need the common difference. This one, you need your first term and then the common difference for the explicit form. So writing those out, here's a pattern. You have to figure out first, well, what's the first term? That's just the first thing in your list. So this is our A1, that's our first term. And then you want to figure out, well, what's the pattern? So going from -8 to -1 to 6 to 13, well, we're adding 7 each time. So your common difference is 7. Now we're just going to plug these in. So recursive, A sub n is going to equal A of n minus 1 plus 7. And then you want to list A1 equals -8. What this is saying here is you take this first term, and then you're going to add 7 onto it to find the next term. And then you take that next term and add another 7 on, and then add another 7 on to find your following terms. So you have to have the term before it to find the next term. explicit formula, we'll plug it in. an is negative 8 plus n minus 1 times 7. And then you can simplify this. So we'll have negative 8 plus 7n minus 7, which then is 7n minus 15. And this would be your explicit formula. Move this up a little bit so you can see. So here's another one. You try this, pause the video, and write the recursive and explicit formula for both of these. All right, so here's our first term. This is the A1. We want to figure out what's going on with each of these. Well, our common difference is negative 17. So you're subtracting 17 each time. So if we plug this in, we'll have a sub n equals a of n minus 1 minus 17, and a of 1 is 20. Your explicit, a of n equals 20 plus n minus 1 times 7. Simplify this out, and you'll get 7n. This should be 17 for all of those. Negative 17. Sorry, lots of mistakes here. So this will be negative 17n plus 37. All right, so the last thing here is how do we actually use the explicit formula to find terms that are like way higher than we want to add to. So here's our sequence. We want to find the 10th term and the 50th term. So if we were going to find the 50th term, that would take a long time to keep adding our common difference over and over and over and over again 50 times. So if you use the explicit formula, you don't have to do that. So looking at this, we want to figure out, well, what's our common difference? So going from 2 to 10 or negative 6 to 2, we're adding 8, and then this is your A1 value. So if we write this out, we have negative 6 times n minus 1 times 8. So we'll get negative 6 plus 8n minus 8, or 8n minus 14. So now if we want to find the 10th term, we just need to plug in 10. So a of 10 is going to be 8 times 10 minus 14. So much faster than having to add 8 a bunch more times and find all the terms in between as well. And we'll end up getting 66. The same with 50. Instead of adding 8 50 times to figure out what it is, you can just plug in 50. So you have 8 times 50 minus 14, and you'll get 386. So that's it for this one. Go on to Math Excel and do the 4.7 assignment.